This begins our 402 project demonstration video. As previously seen from our presentation, this cross-sectional view of the team's CSMU shows the multiple means of thermal insulation to protect the data it contains. Furthermore, this animated exploded view illustrates the system's components, how it is assembled, and the relation of the parts to one another. In total, there's about 72 individual components in this assembly. In-depth engineering analysis was performed on the team's CSMU design. Here you can see an ANSYS transient thermal analysis of the team's design being subjected to the expected heat and duration of the testing requirements. The results from these simulations gave the team key insights for design optimization and a good indication of performance during physical testing. Additionally, the team was able to isolate and quantify the effectiveness of vacuum insulation as an insulating medium for L3 Harris. Based on our results, vacuum insulation alone was able to delay the maximum temperature of our subassembly by an additional 2 hours and yielded a greater thermal inertia as seen in this animation. Following the engineering analysis, the team CSMU was regulation tested in an oven for 10 hours at 500 degrees Fahrenheit. Following the test, the CSMU was pulled from the oven and left to cool. Once cool, the assembly was visually inspected and the memory was pulled from the interior of the assembly. The memory storage devices had little to no thermal degradation as shown. After the visual inspection, the data from the temperature loggers and memory devices were uploaded for analysis. Presented here is an animation of the temperature results of our CSMU during the 10-hour 500 degree Fahrenheit test. Various locations were probed with thermocouples from the exterior oven temperature down to the memory at the innermost portion of the assembly. From these results, we found that the maximum temperature of the memory was approximately 345 degrees Fahrenheit at the 10-hour mark, which is a 155 degree difference from the surrounding temperature. Additionally, the 180 gigabytes of randomly generated data contained on the memory storage devices were extracted and analyzed. Using a custom Python program, the data was inspected down to the bit and compared to the regulation for the allowed amount of memory that could be lost. As shown, the results from our test indicate that the amount of data we lost is well below the regulation limit. To summarize our results and project success, the team was able to achieve all 3 project success criteria. Though the final temperature has room for improvement, the amount of data contained and the amount of data saved far exceeded our stretch goals. This concludes our 402 project demonstration video. Thank you for watching.